Hello friends, welcome to session 2 on SFD and BMD, its problems and solution techniques. Hope you have watched my session number 1, which will cover basic concepts and fundamentals of shear force and bending moment diagram. However, we will review some of them here. I want to recall those two fundamental relations what we have seen in session number 1. First is derivative of shear force is nothing but rate of loading on beam, and derivative of bending moment is nothing but shear force. Now based on these two relations, we have written the relation between loading diagram, shape of SFD and BMD, and just recall that I said when you come from loading diagram towards SFD and then towards BMD, you are going to integrate the things, and when you go from bending moment diagram towards SFD and towards loading diagram, you are getting derivatives. So let us have some recap on all these things. First is concentrated loads. Two effects are there. One is point load and couple, and you rightly seeing on the screen. Shape of SFD, sudden rise or fall when point load is there, but no effect in BMD. But when couple is acting, there is no effect on SFD, but there is sudden rise and fall in BMD. All these things we have already learned in our session number 1. Just I am taking a recap. In case of distributed load, when there is no load at all on a segment of a beam, then SFD is constant line, because no load means, as I said earlier, that 0 for 0 integration is constant, so SFD is constant line, and for constant integration is inclined line, that is sloping line, so BMD is sloping line. Similarly, in case of UDL and UVL, we have discussed everything regarding shape of SFD and BMD. One more point we have to recall that we already said that there are 2 points we have to take care of. One is point of zero shear, and whenever point of zero shear is there, the bending moment value has peak value, because we have relation that dm by dx is equal to v, and when v becomes 0, then this particular function, that is bending moment, has peak value. And second point, we have learned that point of contraflexure. That means whenever bending moment is 0 and changing its sign from sagging to hogging or vice versa, that particular point is called as point of contraflexure. Moving ahead, here are some general steps to plot SFD and BMD. So our step number 1 is draw FBD of given beam. Find support reactions by using equilibrium conditions. But important point I have to note here that whenever you draw free body diagram of given beam, we are interested only in lateral forces and couples, because these two are the only elements which will cause shear and bending. Whomsoever is the axial force, that should not be considered, because it will create only elongation and contraction of the member. So we are interested only in lateral forces and couples. Fine. In second step, we are supposed to do some SF calculations using proper sign convention. In third step, we are going to calculate BM values at various feature points. Now, which are feature points we have to consider, we will see in the next problem with again proper sign convention. And last point is to locate point of contraflexure if at all it is available in bending moment diagram. Fine. So let's move ahead. Here is the first problem we are going to solve. Observe that there is a beam AB supported at A and B and carries UDL of 20 kN per meter. One couple is there acting at D, and one point load is acting at E. So let us move to first step, finding out support reactions. So the beam is there and reactions are shown RA and RB, and let us apply equilibrium conditions. So first condition we are imposing that moment at A equal to 0. So using that condition, I can find out reaction at B. So first force is here, 20 is the UDL and distance is 3. So intensity into distance, that is 20 into 3 is our UDL, total UDL. It will act at midpoint of that rectangle, and this distance we wish to find out. So that distance is 3.5 meter. So this is the moment of that UDL. Then second is couple, it is taken here, minus because it is a clockwise. Third force is 60. So from point A, distance of 60 is 2 plus 3 plus 2. So it is 7. So 60 into 7 is the moment of that load. Again it is a clockwise about A. So minus. And last force is RB. So for RB, distance is from this point to this point. So 2 plus 3 plus 2 plus 3, that is equal to 10. So RB into 10 is the moment, and it is anti-clockwise, that's why taken positive. Solving this equation, we are getting RB equal to 67 kilonewton. As our answer of RB is positive, we may say that assumed sense of arrow of RB is correct. So it is assumed initially upward, so it is correct. Now applying second condition, summation Fy equal to 0, considering this basic sign convention upward positive. So RA is positive here because it is assumed upward. Then 20 intensity into distance is my total load. It is going down, so minus is taken. Then couple will not come in force equations, so that is ignored. And here 60 is downward, so it is taken minus. And our RB answer is there, 67. So solving this, we are getting reaction at A equal to 53. Now second step is shear force calculation. But before that, just remind, I said about the featured points on the beam. How to recognize that? Just to identify the points where loading rate changes. So if I look at the beam, A is my first point, then C is my second point because where UDL starts, D is my third point where couple is acting as well as UDL ends, E is my next point where again one point load is acting, and B is my last point. So this is the way how the feature points are considered. Now for shear force calculation, we are keeping our things simple and straight. What I mean to say, whenever section is taken, we are always looking to the left side of my section. So always we are considering left Bmd of the section, and we are using section slider. I will introduce that concept in just few minutes. As we have total 5 points A, C, D, E and B. So at each point we are taking our section just left and just right of each point. That means total 10 values we are getting. Let's see one by one how it is done. This is my, as I said, section slider. So you may take any piece of paper or your iCard or anything else, and that could be taken as a section slider. So this is our section line. See this green line. This is our section line, and we are sliding this section line from left to right. So starting with point A, but the section is just left of A, and how it is written? VAL, that means shear at A just left. That is the way how it is written. So VAL, observe the left side. As I said, left Bmd we are going to consider. So there is empty space. Empty space means no load. So VA left, I got my first value is 0. Then just right of that A, VAR, that is A right. Now A left I am having, from A left to A right, there is one load observed here. It is going upward. So sections left going upward is taken positive. So this is the old value, and newcomer is 53 going upward, so positive. So answer is 53. Moving to next. A right I am having. Now next point is C. Just left of C is here. From A right to C left, no load is happening. So original value is 53 and newcomer is nothing. So final answer is 53. After C left, move to just right, C right. So C left is available, C right is here. Between these two, again no point load, nothing anything. So original value is followed and no newcomer. So final answer is 53. Our next point is D. So first point is D left, just left of D. So C right we have and D left is here. Between these two, yes, there is a UDL acting. It is acting downward. So as it is acting downward, it should be taken negative. So I have taken the original value and negative sign because of downward load. And load is intensity into distance because it is UDL. So UDL means intensity is 20 and distance is 3. So 20 into 3 is the load and answer is minus 7. After D left, just write D right. So D left I am having, D right is here. Between these two there is no point load, nothing is happening. So original value is taken and newcomer is 0. So answer remains minus 7. After D right, next point is E left, just left of E. So D right we are having the value and E left is here. Between these 2 points there is no load. So original value is taken as here and newcomer is 0. So answer is minus 7. Now you may wonder that what happens with couple. Remind the property seen in that table. Whenever couple is acting, shear force diagram does not have any change because couples are considered in moment equations and shear force is only the summation of forces. So couple doesn't have any effect on shear force diagram. Okay, E left is over. Now next part is just right of E, E right. E left is here. That value we are already having. E right is here. Between these two, yes, there is newcomer is there. It is going down. So it is minus and 60. So original value is here, E left. Newcomer is minus 60. Answer is minus 67. Now we will come to last point B. B left. E right we are having. B left we are now going. Between these two there is nothing is happening. So original value is taken and newcomer is 0. So final answer is minus 67. After B left, move to B right. So B left we are having, B right is here. Between these two there is one load which is nothing but reaction at B which is going upward. So original value is taken and reaction at B as it is going upward it is taken positive. So final answer is 0. Let me tell you how to check our calculation. Always remember that first left is always 0 and last right value is always 0. These values must start with 0 and must end with 0. It means that our SF calculations are absolutely correct. Correct? After this, now we are ready to plot the diagram, shear force diagram. And for that, we have to take one baseline which represents the axis of the member. That means now beam is our horizontal member, so axis of member is there. And vertical ordinates are nothing but our shear forces. And we are covering one by one point. So first value is A left. So it is plotted here, A left. Start with 0. Then second value at the same point A, but plus 53. So this is plus 53. And these 2 points are joined. So this is the way first point is plotted. So this is over, this is over. Now next point is C left. So C left is plotted here. So this is my C left. It is plus 53. So it is plotted here. And these 2 points are joined. Then C right. It has same value. So C left and C right are same. So there is no change at all here. Then next point is D left. So D left is this point. So let us plot D left which is minus 7. So it is plotted here. D left is minus 7. Now these 2 points are supposed to join. To join these 2 points, you have to identify that table property. Whenever UDL is acting on beam, shear force diagram is inclined line. So that way we are going to plot that D left. After D left, next point is D right. Again same point. So D left and D right at same point. So it is plotted here. Once that D is plotted, now A is covered, B is covered, C is covered, D is covered. Next point is E. E left. So E point is here. So next point is E left. So this is my E left minus 7 So joining these 2 points by straight line, because there is no load means horizontal line. After E left, next point is E right. So on the same E, it is minus 67. So it is plotted like this. This is E right, minus 67, join these 2 points. Once these 2 are plotted, next point is B, last point. Again minus 67. So it is plotted here. B left is minus 67, join these 2 points. And last is B right, it is 0. So this point is there, B right. Join these 2 points. This way I am completing my shear force diagram, right? Now, according to our properties of shear force, that table what we have seen, we have to check holistically whether my shear force diagram plotting is correct or wrong. First of all, first checkpoint is a point loads. Observe, this is a point load at A. And as I said, whenever point loads are acting on beam, shear force diagram is rise and fall. Upward point load, so it is rise. Downward point load, so it is fall. Upward point load, so it is rise. Second checkpoint is that whenever no load is acting, SFD is horizontal. No load is acting, SFD is horizontal. No load is acting, SFD is horizontal. Second checkpoint. Third checkpoint, whenever UDL is acting, SFD is sloping line. As UDL is downward, so SFD must be sloping downward, right? And last checkpoint, whenever couples are acting, SF doesn't have any change. So these are the some points which are very important to check after drawing your diagram. But one more important when you plot, that is point of zero shear. This point we get it. So what we will do, we are interested to find out the location of this particular point. So let us call this as a x distance. I have taken x from left because it is simpler side. You may take x from right, no problem at all. Right now, I have taken x from left point A. Now I am extending this point to my loading diagram. And this FBD we are going to consider. Correct? So it is here. Left side FBD is plotted. So this is our section line. And left side FBD, because we have taken x from left, that FBD we have plotted. Now we are interested to write bending moment equation for this particular section line. So let us write that bending moment equation. Yeah, this is here. Bending moment equation for this section. 53 into x. It is going like this. And as I said, it is bending moment equation. For bending moment equation, we know that sagging is positive like this. And I given one more term. You can call it as a happy, or you can call it as a out. So out is positive, that is sagging is positive. So 53 into x out, so plus 53x. Second load is UDL, section is here, this much is the UDL. So intensity is 20, distance is x by 2, acting at center, x by 2 upon 2. So moment of that UDL is 20 into x by 2 whole square divided by 2. Observe that this UDL is acting downward, which will create hogging type moment, or another word you say in. As I referred the term, in is negative, out is positive. This is in. So in is negative. So it is minus sign is taken. Once I got my this equation, we also know that dm by dx is equal to v. And here at this particular point, shear force is 0. So what I am doing, this derivative of bending moment equation is equated to 0. That means I am doing v equal to 0 so that I can get that particular distance x. Solving this equation, I am getting that distance x from A. So this distance I am getting the location of point of zero shear. This is the way I am getting location of point of zero shear. Now move to step number 3, bending moment calculation. Here also we are doing things simple, but like SFD, we are not doing every time left and right of each point. Not necessary, because we know perfectly that whenever couple is acting, then and then only just left and just right is necessary, because in bending moment diagram the sudden change will occur only when the couple is acting. So observing our beam, we observe that there is only point D where the couple is acting. So only at point D we are doing two calculations of bending moment. Otherwise, at all remaining points, single calculation at each point is sufficient. Fine. Okay, let's start one by one. Again, same section slider is taken, always considering left FBD of my section. So my first section slider is here. And remember that our sign convention is this, sagging is positive. And I give you a simple idea, if section is there, out and out, it is nothing but sagging, we are taking it positive. And for any section, in and in, that is we are taking negative. This simple logic we will remember instead of that sagging and hogging. Okay. First point is A. Bending moment at A, exactly at A. Observe left part, there is empty space. So bending moment at A is 0. Next part is our point C. So exactly at point C, observe left FBD we are taking. So force is 53 and distance is 2. So 53 into 2 is the moment. Question remains, who is the sign? So for that I said the moment is like this about the section line. So out is positive. So we have taken positive. So this is the answer, moment at C. But at point D, we know that couple is acting at D. And therefore, one section should be just left and another section should be just right. As we know, whenever couple is acting, there is a sudden change in bending moment diagram. So we are taking two sections. So first section is D left. Observe left FBD, it is here. So we are going to take moment of two forces, one by one. First is 53, distance is this. So 53 into 5 is my first moment. This is the first moment. It is going out. So positive. So that is the first case. Now second case is UDL. So intensity into distance acting at midpoint here. So intensity into distance 20 into 3 acting at midpoint. So I want this distance from my section point. So this distance is 1.5. So distance is 1.5. Now observe that UDL is acting downward and it is creating moment in type about this section point. So coming in is negative. So minus sign is taken. So 20 into 3 into 1.5 is the moment. Negative because of hogging nature or in type moment. Answer is there. Moment at D just left. Now just right we have to consider. Now as the same point is there, why I should again calculate every moment here? Not necessary. Only I will consider what is the new, because from D left to D right I have to go. At D we got a couple. So now D point is seen. So couple I have to consider. So couple is acting clockwise here. But on left side the clockwise means like this. Observe this arrow and just investigate whether it is going out or coming in. You observe that the blue color arrow is going out. So it is couple value is 40. So it is taken positive. So this value is taken as it is, original value, and this is the answer. Next is point E. Here there is no couple, so directly one value is taken. Again, all left side I have to consider because that is a new point. So therefore, all values are considered. So one by one we will take the moment. First is 53 is the force and distance is this one. So that is 2, 3 and 2. So 53 into 7, it is out. So 53 into 7 is out, so positive. First part is over. Now take the UDL into picture. 20 into 3 is the UDL. It is acting at this point and distance required is from midpoint to the section point. So that is 2 plus this particular distance is 1.5. So it is 3.5. Observe UDL creates in type moment. So minus is taken. That point is also clear. Now last point is couple. Couple is acting something like this. Clockwise couple. So section's left part. Clockwise couple means out and out is taken positive. So answer is 180. And last point is our B point. Now for B point, all this particular area I should consider as my moment part. So one by one we will start. Observe, this is the distance for 50 kilonewton force. So 50 into 10 going out, positive. Then UDL is 20 into 3 is the UDL. Distance is from this midpoint up to the section point. So that distance is 6.5 meter. UDL is coming in, so negative. Then couple, it is shown here. Couple is a free vector, you can show it anywhere. So every time I am moving the couple so as to identify whether it is going in and out. So this is simpler way to identify. So it is out, so it is taken positive. Then force is there, 60 into this distance from the section. So 60 into 3, it is coming in, so minus. So final answer is 0. Here also I am getting one check. I am starting with 0 and I am ending with 0. It simply means my bending moment calculations are also correct. But do you identify one basic difference in these calculations for SF and BM? In SF calculations, we always carry old value and just newcomer is added. But in bending moment, we are not doing the same thing as it is. Because you understand that bending moment means force into distance. So here distance comes in picture. So at every change in section, the distance changes. So I can't carry old value as it is for newcomer. That's why every time I am going to take the moment. So that is the basic point you have to understand. Once that all values are covered, now I am interested this particular point, because we know at point of zero shear bending moment is maximum. So I am interested to find out that maximum bending moment value. Just recalling the equation what we have written earlier, we already written that equation of bending moment and we already got that distance 4.65. Only my job remains to put this value in this equation. I am getting Mmax. So 176.26. Thus we get a max value which is lying in segment CD 176.23. Now while plotting BMD, we should take care that this Mmax value lies between C and D. So that care we will take when we plot our BM diagram. So let us take one baseline which represents the axis of beam, and we will plot the values of bending diagram as y coordinate. The first value we have to plot is moment at A and second value is moment at C. So these two values are plotted here. So moment at A is 0 and moment at C is 106. Joining these 2 points by straight line, because according to our concept, when shear force diagram is horizontal, bending moment diagram is inclined line. First point is over. Now moving from C to D, we also know that there is a peak value which is founded here. So I should plot this value and this value simultaneously. So bending moment maximum is 176.23 and D left value is 175. So let us plot those values. Just observe on the screen. It is like this. So this point we are already having peak value when shear force is 0. We have peak value. It is already plotted here. And at D first value is left. Question arises how to join these 3 points. Again we will go back to our fundamental that whenever UDL is acting on beam which is constant line, the shear force diagram is inclined line. That point is over. And when shear force diagram is inclined line, our bending moment diagram is a second degree curve. And we also know that whenever UDL is acting downward, our BMD has concavity down. That's why this curve is joined in this fashion, concavity down. Okay. Now after D left is plotted, next point is D right. At the same point, D point, D right. So it is plotted here, D right. So this is the rise we get from D left to D right, and there is a sudden change because of couple. After D right is plotted, now next point is our E point, bending moment at E point plus 201. It is plotted here. Again observe these 2 points are joined by a straight line because of our logic that Whenever shear force diagram is horizontal, its integration is inclined line. So BMD is inclined line. And last point is bending moment at B. So this is the point. Again, we have joined these 2 points by straight line. Same logic. SFD horizontal, BMD inclined line. Right? So this way we have plotted our diagram of BMD. Like we have checked the SF diagram, we also check our BM diagram as per our logic. 2-3 points we have to observe. Whenever no load is acting on beam, bending moment diagram is inclined line. No load, inclined line. No load, inclined line, or you can call sloping line. That is first check. Second, whenever downward distributed load is acting, BMD is parabolic curve, concavity down. Third point, we have to check that whenever couple is acting, there is a sudden rise or fall. For clockwise couple, sudden rise, and if at all any anti-clockwise couple, then there will be a fall. So here right now it is clockwise couple, so there is sudden rise. And for point loads, there is no change. So observe, there is no change for point loads, right? So these are the fundamental points how to check our BMD.